all of you. In today's session, we will discuss one of the numerical based on multiplexer, that is implement the following function using 8:1 mux. In our previous video, we have discussed that 8:1 mux, conversion of 8:1 mux to 4:1 and 2:1 mux. Again, that multiplexer tree. So based on this, that numerical, that is or problem, that is implement the following function using 8:1 mux. So proceed with the same. That f, that function is given. That function is f is equals to summation minterms 0, 1, 3, 4, 8, 9, 15. Okay, that function is given in the form that is 0 to 15, that 0, 1, 3, 4, 8, 9 and 15 as summation minterms. As summation minterms, as here, meaning of that summation minterms, here summation minterms is basically the SOP form, that sum of a product form, in this sum of a product form, that 0 is basically as complement and 1 is your original literal is considered. Okay, now here again that question arises that here the function is only given but not variable, and again that given 0 to 15, but again it is not clear that that function variable, and it is how many variable we have to use, yes or no. So for that purpose, what we have to do, we have to just consider that first literal and the last literal. Okay, so here that first in the function started with a 0 up to 15, 0 to 15. So the last number as digit here 15. So if we consider that 0 to 15 started with a, again that formula 2 raised to power n is equals to m. So we are having the 2 raised to power 2 is equals to 4, 2 raised to power 3 is equals to 8, 2 raised to power 4 is equals to 16. Yes, so here if the number is in the above 8 is above than 8, yes, and the number is less than 15, yes, the number 15 is greater than 8 and the less than 15, or the greater than here less than here 16. So here that's why we have to use the variable that 16. So here 2 raised to power n. So from that relation we can say that we have to use the n is equals to 4. Okay, so n is equals to 4. So that's why the function is in the form a, b, c and d is equals to. But again the question arises that we have to use, as they suggest, we have to find out or implement the following function using 8:1, and given function is in the form that is 0 to 16. So how we can convert, we'll proceed. Okay, so here that function so from the above discussion, that function f of a, b, c, d is equals to summation minterms that 0, 1, 3, 4, 8, 9 and 15. So for that we have to just draw the functional table. For this we have to just draw the functional table for this. Functional table consists of input as a, b, c, d, and the output, I must say that the function f. Okay, here, so here that function start with 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0 0 1 1 1 1 0 0 0 1 0 0 1 1 0 1 0 1 0 1 1 1 1 0 0 1 1 0 1 1 1 1 0 here 1 1 1 1. So here the function 1 by 1, if you see as the given function for this 0, it is going to be 0. For that 0 it is 1, again 1, as is 2 is 0, as 0 1, next is here 3, it is 1, so it is 0 1 2 3, next is 4, next is 5 0 6 0 7 0 8 1 9 1 10 0 11 0 12 0 13 0 14 0 and 15 1. So this is what the function here, this is what the function. Now we have to just convert it by using 8:1. So for that we have to just draw the again functional table for 8:1. Now here 8:1, so 2 raised to power 3 is equals to 8, so 3 variable. So we have to just consider A, B and the C, and again that function, that f. So here if you consider that function now for 3 variable, but how to convert, in our previous video or my video we had discussed how to convert that 16 to 8. So here we have to just pair that of 2. Next, by using the relation, just directly we can say that here if we compare with our term with d only, so here that function with d, that is 1, so it is what logic 1 because 1 1 here, and 0 1, so same, so it is what d. Next here that 0 1 1 0, it is exactly opposite, so it is a complement. That 0 0 as same, so here 0. Next it is 1, it is what 0 0, again it is 0, again it is 0 and 0 1, so same, so it is d. Again we can say that 0 1, so it is 1, it is 0 1 0 1, same, so d. It is opposite, so it is d. Bar, it is 0 0, so it is 0, again it is 1 1, so 1, 0 0 0, again 0 0 0 and 0 1, it is d. So in this way we are having with 8 data input, so we have to just again just by using 0 0 0 we can say that 8 input, or directly we can find it to what 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. So here that first is 1, the second is d bar, next is here 0 1 0 0 and here 1 0 0 and here the term d. Okay, so in this way we can convert it into that 16 to 8. After that we have to just implement the following by using 8:1. Now here we have to just draw the 8:1. Here we have to just draw the 8:1. Here the output, that y, here 8:1 marks that select line 3 as, no doubt here we can see that select lines as ABC. So inputs as ABC, and here as logic 1 here we can say that this is what your logic 1 line. Next, that line D, input D, this is what inverter, that for D bar, and here that logic 0. Okay, so this is what your logic 0. So first of all we have to just say that 1, 2, 3, 4, 5, 6, 7 and 8, that 3 inputs D0, D1, D2, D3, D4, D5, D6 and D7. So we have to just say that the first is input, we have to apply 1 to logic 1. So 0, 0, 0, D0, here D0 is what? Logic 1. So connect to logic 1. Next D1 to D. Next D2. If you say that D2, so D2 is D bar. So connect to D bar. Next is what your D3. D3 is logic 0. So D3 is going to connect to logic 0. D3 is connect to logic 0. Next D4. D4 is logic 1. So it is connected to logic 1. D5 is 0 and D6 also 0. So D5 and D6 is 0, logic 0. And this is what D. D7 is connected to D. Okay, so in this way you have to just draw that functional diagram for this 8:1 mux. This implement the following function using 8:1 mux if they given for 16 also. Thank you.